geometry students. I hope you're doing well this Wednesday and that everything is clear about how we're going to proceed until the end of the year. So today we're going to do our second day of review. If you are really comfortable with all the material in chapters 10, 11, 12, feel free to just get started on your homework. But if you want to have some review to recall how to do certain problems, then please join us in this video. So I'm going to say a prayer. Father in heaven, I just thank you so much that you're faithful and you're good. I pray that you would strengthen me and help me to be the very best teacher I can be right now, and that you would bless my students, help them to focus and recall everything so that they feel confident in their understanding of geometry. In Jesus' name, amen. Okay, so just so you know, there is quite a bit of review. So we've got chapters 10, 11, and 12. I'm only going to do 3 or 4 problems from 2 or 3 problems from each one. And then it's not going to be due until late next week. So you can turn in the test and all this review all at once. So let's get started. Okay. I already drew all the pictures. So go ahead and draw this picture. And we want to find C. I think it's especially important to go over chapter 10 because that was quite a long time ago. I think we were doing that in about March. So you can always have your foldables out with you, but basically if you have 2 lines that come from a point and they're tangent to a circle, then their point of tangency, they create congruent segments like this. So if we're trying to find C, I can just set both of them equal to each other. Now there were several of these theorems and it's hard to remember them all, and some of them are slightly different. You know, there are different ones where you have 2 segments like this, then you had one going through like that, or you had one that came to the edge. There was all kinds of things. So you just have to use your foldables and plug the numbers into the formulas. So let's solve for this. I'm going to subtract 9C. And I'm going to subtract 14. So I can get all the C's together on one side. And these 9C terms drop out. So then I have 6 minus 14 is 8. And that's equal to 0. Because I want to have all the C's together on one side and then the number on the other. Now I'm looking at this and I'm going to factor out a 2. So I divide every term by 2. Oh, look at that beautiful thing. That is a perfect square that we can factor. Now, if you're in my algebra class, then you would know we put a 0 term in here, and then we can use magic X to factor. So what multiplies to be -4 and adds to be 0? Well, 2 and -2. So C minus 2 and C plus 2. And I set them each equal to 0. And I get 2 and -2. And of course I can't have a negative length, so the answer is 2. If you don't remember this process from Algebra 1, if you look up Magic X on YouTube, you will find a video about it. I actually taught a video to my Math 8 students called Magic X, so you could look me up in this. Or if you have another way that you know from your last algebra class how to factor this, please feel free to use that. There is a formula that's possible to use also. Alright, so I'm going to erase some of this because it's running into my next drawing. That is number 1. Okay, number 2, we have a circle here, and we want to find the different arc measures. Okay, so this is the arc measure, which is the amount of the curve. It's a degrees rather than the length. The length would be the actual how many centimeters or inches long that part of the circle is. We're not looking for that. We're looking for the curve, the angle of the curve. So MN would be right here. And of course, with the center in the middle there, that means we have a central angle here, so that the arc measure is the same as the central angle, and that's 120. Okay, now be careful how you read this. We read this NLM. order matters. So I'm looking at N, L, M. So that's going to be this part of the circle. It's the whole angle there. Now I know a whole circle is 360, so if I subtract this part, then I get 240, and that's my answer. All right, now let's look at a different arc. I'm looking at N, M, L. So do you see these two have the same letters, but they're in a different order, and so that really matters how you read what arc we need. So I'm going to go N, M, L. So that's right here. And I can see, even though I don't have this part of it, I can see that LN is a diameter. So it's going to be 180 because LN here encompasses the whole thing. So that's my answer for those. Let's do number 3. Go ahead and draw that picture, and I want to find X. Now what you need to remember from this is the relationship between an inscribed angle and its corresponding arc. So an inscribed angle looks like this. Inscribed means it has all 3 significant points on the circle. It's not in the middle, central angle, but it is over to the one side. So an inscribed angle is the angle measure. So the inscribed angle is half of its arc. So if I'm looking here, then I know that this arc is 80 degrees. My clue in the picture is that I have 2 inscribed angles here, okay? Now I have another inscribed angle, and that happens to have the same inscribed arc. So it would go backwards, and I end up having this angle X be the same measure as the one I had. Okay, we're going to do one more. Number 4, and this is one of those problems that has the special equation and a formula for it, and I want to find this angle measure here. So what that is that the measure of angle X equals half of the subtraction of PR, minus NQ. Now those are using the letters that are on my picture, but if you looked it up on your foldable and found this picture, you would see a corresponding formula. So then I'm going to take half and I'm going to subtract 122 minus 58, and I will get my answer. So 122 minus 58 is 64, and if I take half of that, I get 32 degrees. Really, it's not that bad, okay? You just have to keep the formulas straight. All right, so let's move on to Chapter 11. I found a problem. Chapter 11 is mostly about areas of polygons, from the simple ones all the way to the more complex. So I picked this one to show us how to do a compound polygon, which has 2 smaller figures in it, and we get to practice a couple of those. Now, what do I know from the picture? I've got 4 congruent sides, which means it's a square, all right? So the area of the square is going to be S squared. And how long is that? Well, it's 16 squared, which is 256. So that's the area of my square. Now I have this triangle, and the formula for that is 1/2 base times height. Well, how long is the base? Well, if this is 16, then this would be 16 here. Okay, I'm actually going to write it on the inside. Now, I need to draw in my height, and I need to have my height. How am I going to find that? Well, you can see they give us another clue down here with this whole length. And if I know that this is a square, then this side is 16, then my height, which would be right here, is 40 minus 16, and that is 24. Okay, so I'm going to use those. And I have 1/2, and the base is 16, and the height is 24. Okay, so if I work that out, I see that 24 times 1/2 times 16 is 192. So now I'm going to add those two together, and I get 448 centimeters squared. Okay, number 2 on this one is having to do with ratios and perimeters. All right, this came up quite a bit. Find the ratios of the perimeters and the areas, and then find the area of my larger parallelogram. Okay, so I can use ratios to figure this out. They give us the area of the small one. Now, what's important to know here is that what does ratio of perimeters mean? Well, whatever the side length ratio is, that's the ratio of perimeters. So the ratio of perimeters is the same as the ratio of lengths, so that would be 10 over 13. Okay, and now to find the area, what I need to do is whatever my length is, I have to square it to get the area ratio, right? So that means 10 squared over 13 squared, okay? And here is where I put my 90. I put 90 on the top because 10 goes with the 90, all right? And this becomes x down here. Okay, so 10 squared is 100, and 13 squared is 169. And I cross multiply. Let's see what we get. 169 times 90, and I get 15,210, and I'll divide by 100, and I get 152.1, and that is, they didn't give us any lengths. Let's call it inches. So this would be inches squared for area. Okay. The reason why I go over that is I think that was one of the sections you had the most trouble with, and we've already done a lot of the hexagons and polygons, or pentagons, those larger shapes with the Potham, and I think when you do the review, you'll be fine doing those. All right, let's do number 3. Find the arc length. So I picked this rather than area, but the formula works the same. So the arc length over my circumference equals the arc measure over 360, okay? So what do I know here? I don't know the arc length, so I'm just going to call that arc. And I know the formula for circumference, that's 2 pi r. And I know my arc measure, which is 115. So now all I need to do is put 13 in here. Okay, so I'm going to do arc, and then 2 pi times 13 equals 115 over 360. So my arc measure is 26 pi equals 115 over 360. And if I cross multiply and divide, I end up with an arc measure of 26.09. So I cross multiply here. Okay, so that's how you do number 3. And if it was area, if we had an area here, you would just use pi r squared here, and you'd have your area of your section where the arc is written. All right, let's do a couple from chapter 12. Let's start with surface area, and I chose a cylinder. Now, when we're doing a surface area, we want to have a plan. So we're going to have 2 circles plus 1 long rectangle in between. So I want to find the area of the circle and the area of that rectangle, because again, if we open up the rectangle This is going to be 2 pi r here, that length. All right, so the circle area is pi r squared, and I get pi times 15 squared, and that works out to be, oh, whoops, no, I'm sorry, it's 9. It's going to be 81 pi for each circle. All right, and then for my wrapped up middle rectangle, I've got 2 pi r times the height here. So this is the height. So I'm going to have 2 pi times the radius 9 times 15. And if I multiply that, I get 9 times 15 times 2 is 270. So here I'm going to have 270 pi. So my surface area is going to be 2 of these circles and 1 of the rectangles. Okay, so I'm going to work that out, and I get 162 pi plus 270 pi, and that equals 432 pi. And if I work that out, that ends up being about 1356.48, and that is inches squared because I'm doing surface area. All right, let's do one more on the back of these types. We're going to try volume. Now, the volume of a pyramid, you have to know your formulas, is going to be 1/3 base area times height. So for pyramids and cones, it's 1/3. If it's just a prism and you're finding the volume, then it's just the base area times the height, no 1/3. So let's put everything in. So my base area, let's start with that. The base area, they're telling me, is 18 here long, and it is a square. So that's going to be 18 times 18, which is 324. So my volume is going to be 1/3 of 324 times the height, which is, I'm going to put parentheses here, 11.5. So if I take 324 multiplied by 11.5 and divide that all by 3, I get 1,242 feet cubed this time. Okay, volume is cubed. All right, one more. I find that students tend to have some problems with the ratio, so I wanted to do another one of those. Find the surface area and the volume of the solid. Solid B. So here is solid A, and we know that the ratio of the scale factor is 3:2. And the surface area of A and the volume of A are given. So we're going to set up some ratios, right? So now for area, my ratio is squared. So I take 3/2 and I square it, and I get 9/4. So for area, the surface area, I'm going to take 9/4 and I'm going to make a ratio. So then I have 324 over pi over x. So remember, it's A to B. So when they say A to B, it's 3:2. So you've got 3/2, and then the one I'm given is A, and that goes on top. So when I cross multiply, I get 1296 pi, divide by 9, and I end up with 144 pi, and that is units squared. So there's my surface area. Okay, so now when I'm doing volume, I have 3/2 cubed. So that's 3 times because I have 3 dimensions. So when I do that, I get 27/8. So this time I use 27/8 equals 972 pi over x. And I'm going to cross multiply, and I get 7776 pi here. And then I end up with 288 pi, and these are units cubed. Okay, so that's the last one we're going to cover. I will have Zoom tutoring on Thursday, and mostly I want to spend time on chapter 12. But if some of you come and you have other questions, I'm happy to help you. So I hope you have a great Wednesday, and we will be in touch soon. Bye now.